Sadly, I forgot that I had to redo this one too. Consider the geometric sequence 4, 2, 1. And let's do 6, 2, 2/3. That's a geometric sequence. I know it's geometric. For one, I created it. But your R value is 2 over 6, which is 1 over 3. And that holds, okay? You can also check it again. You'd say 2 over 3 over a 2. And the magic thing is about these 2's being in the same position, you get 1 over 3. So it holds. It's a third when either way you look at it. So the rule for this thing, again, I'm using ace of n is ace of 1 times r to the n minus 1. The first term is 6, and my ratio is a third. So the rule is 6 parentheses 1 over 3 to the n minus 1. It says, if possible, determine the infinite sum of the sequence. So the sum of an infinite sequence is the first term over 1 minus r, so long as the absolute value of the ratio is less than 1. We call this a converging series. It converges on a 0. Doesn't actually get, it's funny, but anyways, it's doable. It's pretty amazing. It's doable, and it's pretty amazing that it's this frickin' simple. But anyways, my first term was a 6. 1 minus r, which was a third. Feel free to do this by hands. That's 6 over 2/3, which is 9. You know, if you can do it by hand, it's not that big a deal. I'm not actually asking you to. It'd be cooler if you could. It'd be way cooler if you could do this by hand. But just like the function we used to pull up the fraction, that's how you guys are. You're numb. 6 over 1 minus 1 over 3. Now, don't be thinking you're going to become an engineer or a STEM major. You can't do fractions, because you can't. You won't. You will flunk out. You got to learn them fractions. It's 9. All right, 2 more to go, and then I can leave for the day and enjoy my weekend.